What you might have been told in your classes or in your algebra class is if you would look to simplify your denominator completely. That means a couple things. If you have any perfect square factors to remove or perfect nth root factors to remove from your denominator or from the radical, do that. Also, it means if you can rewrite your number, your base inside the radical as in an exponential form with a smaller base, do that as well. So that's something that we'll see on the next slide. But you might have been told to simply take the square root of whatever you have and multiply it by that over itself. And you can do that because something over itself is a value of 1. Multiplying by 1 is an identity property, so it doesn't change the value. And so this is probably how it was presented to you to rationalize if you have already gone over this. I'm going to show the same things, but I'm going to talk it through in a slightly different way. And I'm going to talk it through as this step 2 shows. Okay? When I look to rationalize, I'm going to multiply the top and bottom by the same indexed radical. So here, in this case, it's a square root. The same base inside my radical. So in this case, it's a 23. And then what I'm going to do is I'm going to build my powers in the denominator up so that my total sum of powers is equal to the index. And so the index in a square root is 2. When I look at my original radical, I have a base of 23 to what power? It's an unwritten 1. So in order for me to build up the powers so they equal the base, I need 23 to what power so that the total sum of powers equals 2? I just need one more, right? Because now I have the original 1 plus this second 1 gives me 2. And I'm able to build up my power. And the reason I do that is I want this form the nth root of a to the n, because then that's either going to equal a or the absolute value of a. And so I'm looking to remove my radical from the denominator in that way. So when I multiply across the top here, I get negative 10 root 23, all divided by, and the whole idea is root 23 times root 23 is root 23 squared, which just cancels out to that base 23. Since nothing cancels out, or no common factors cancel here, negative 10 root 23 all over 23 would be your solution. Okay, so I'm going to walk through one more time and talk through these steps. Okay, so if I have radicals, both the numerator and denominator, doesn't matter, still the same thing. I'm going to reduce my radical in the denominator, root 6, no perfect square factors to remove from there. So when I rationalize, I'm going to use the same radical, square root, the same base 6, and I'm going to build up my powers so they equal the index. My index is 2. I have 6 to the first, so how many more 6's do I need so that my total sum of powers is equal to my index? Just 1. Okay? And when I multiply here, 13 times 6, I get 10 times 6 is 60. 3 times 6 is 18. 60 plus 18 is 78. All over root 6 times root 6, I just pull out the base, the root and the power cancel, leaving my answer as root 78 over 6. If you have a number that has a portion outside of the radical 2, there's no need to include that when you rationalize. If you were to put 4 root 3 and 4 root 3, it doesn't give you any advantage because the 4's are going to cancel anyway, those factors, so you don't even need to include them. So when you rationalize, you're simply going to use the portion in the radical. Okay, reduce what you can. Root 3 doesn't reduce at all. So when I rationalize, I'm going to use the same radical, square root, same base, 3. I'm going to build up the sum of my powers to equal the index. My index is 2. I had 1 3 to begin with. I need one more. Write that over itself. And I get my answer, negative 15 root 3 all over 4 times root 3 times root 3. Again, it's just the 3. Notice here I can simplify. 3 goes into 15 5 times, and so I wind up with negative 5 root 3 all over 4 as my solution. Okay, the final example. Okay, when I'm working through this, root 14, there's no perfect square factors I can remove, so when I rationalize, I'm going to use the same radical or square root, same base 14, and the same idea. I have 114 to start with. I need one more in order to build up the power to equal the index. And so I wind up with 42 root 14 all over 14. And that would be my solution. 14 and 42 do have common factors. 7 goes into 14 twice, into 42 6 times. I still have a 2 and a 6, so 2 goes into 2 once, into 6 3 times. Give me 3 root 14 as my answer.